black hole at the center of our Milky Way galaxy, seen bubbling with activity. And this is what they see. The supermassive black hole at the center of our Milky Way galaxy may not be as ferocious as the gas-gobbling monsters that astronomers have seen farther out in the universe, but new findings from NASA's James Webb Space Telescope reveal that its surroundings are flaring with fireworks. James Webb readings in 2 near-infrared wavelengths have documented cosmic flares that vary in brightness and duration. Researchers say the accretion disk of the hot gas surrounding the black hole, known as Sagittarius A, throws off about 5 or 6 big flares a day, and several smaller bursts in between. The observations are detailed today in the Astrophysical Journal letters. In our data, we saw constantly changing bubbling brightness, and then boom, a big burst of brightness suddenly pops up. And then it calmed down again. Suddenly, lead author Farhad Youssefzadeh of Northwestern University, Illinois, said, "We could not find a pattern in this activity. It appears to be random. The activity profile of the black hole was new and exciting every time that we looked at it." Youssefzadeh and his colleagues observed Sagittarius A using James Webb Space Telescope near-infrared cameras, or NIRC-CAM, for a total of 48 hours, broken up into 8 to 10 hour increments over the course of a year. They expected to see flares, but they did not expect the black hole's surroundings to be as active as they are. The researchers suggest that 2 separate processes are sparking the light show. The smaller flares may be due to turbulence in the accretion disk, compressing the disk's hot magnetized gas, and such disturbances could throw off brief bursts of radiation that Youssefzadeh likens to solar flares. And he explained it's similar to how the sun's magnetic field gathers together, compresses, and then erupts a solar flare. Of course, the processes are more dramatic because the environment around the black hole is much more energetic and much more extreme. The bigger burst could be due to magnetic reconnection events, and that would occur when 2 magnetic fields collide, throwing off bright blasts of particles that travel at velocities near the speed of light. And he said the magnetic reconnection event is like a spark of static electricity, which in a sense also is an electric reconnection. Another unexpected finding has to do with how the flares brighten and dim when seen in 2 different wavelengths. Events observed at the shorter wavelength changed brightness slightly before the longer wavelength events. And he said this is the first time we've seen a time delay in measurements at these wavelengths. We observed these wavelengths simultaneously with NIR-CAM and noticed the longer wavelength lags behind the shorter one by a very small amount, maybe a few seconds to 40 seconds. Those observations could serve as clues to the physical processes at work in the disk swirling around the black hole. It could be that the particles thrown off by the flares lose energy more quickly at shorter wavelengths than at longer wavelengths. It's a pattern you'd expect for particles spiraling around magnetic field lines in a cosmic synchrotron, he said. And now researchers are hoping to get a longer stretch of time on James Webb Space Telescope, which should help them reduce the noise in their observations and produce a more detailed picture of what's going on at the center of our home galaxy. Youssefzadeh said when you're looking at such a weak flaring event, you have to compete with noise. And if we can observe for 24 hours, then we can reduce the noise to see features that we were unable to see before. That would be amazing. And we could also see if these flares repeat themselves or if they're truly random. The article was originally published in Universe Today, and this is on Science Alert, written by Alan Boyle, Universe Today. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.